guess I can even structure it better. Within the scope of a Comp 308 class, within the scope of an introduction to finance class, there's really one flowchart that you want to use that's going to be a total game changer for you when solving time value of money exam questions. And it's exactly what's on the screen right now. I believe that this flowchart will literally tell you exactly which formula to use and what variables to look for and to solve for on an exam. If you didn't have this already on your cheat sheet, do it now. Really add it because it'll help you figure out every single thing you need. And it's really going to help you on your exam. And that's why it's important for you to get familiar with it right now while you're practicing 2 weeks or even, I guess, 10 days removed from the midterm. Now, this flowchart, really quickly in the chat, can everybody see it? Just a quick yes or no. Is it visible? Like, is it legible? Can we see it? Okay, cool. Amazing. So with that said, within this flowchart, we're looking at 3 key indicators, okay? Essentially, how are payments occurring? Are they occurring for a defined period of time or for an indefined period of time? In other words, are they lasting forever? That's the first sense check, okay? So we're gonna kind of highlight it together. So the first sense check is to look at our payments and decide whether these payments are happening for a defined period or for an indefined period, in infinity, a perpetual amount of time, okay? That's the first sense check. And if you look at the flowchart, I even added a little legend ahead of each boxes, or above each boxes, actually. As you can see here, in this, for a defined period, if we were to go up right here, you can notice that the timeline is literally showing you a defined period of time. It's showing you T0 all the way to T5, but there are only payments for T1, T2, T3, and T4. That's in defined period. Payments that are happening at one date and finishing at another. On an exam, they will tell you, hey, payments are done then. If they tell you that, we are dealing with payments that are for a defined period, okay? But conversely, on the other hand, okay, we could look at an undefined period, okay? Now, if we look at our timeline, you can notice that we have a little infinity symbol, okay? Payments are going through our timeline. They're lasting forever, okay? So they're going to happen at T1, T2, T3, T1 million, T infinity plus 1 million, etc. That's the first sense check that you want to do on your exam, okay? The second sense check that we need to look at, which is only really going to happen if we are actually going up right here. So if we were to say, okay, our payments are happening for a defined period, then the only real time that you're going to use this sense check is only if your payments are happening for a defined period. If they're happening for an undefined period, as you can see in the flowchart, we don't need to deal with it. I'll talk about it later. But if it is for a defined period, you want to look at 2 things. Well, when are these payments occurring? Okay, are they occurring at the beginning of the period or at the end of the period? That's going to be super duper important because it's going to change the way our timeline looks quite a bit, and it's going to change the type of formula and the type of time value of money topic we're dealing with. All right. So let's begin with if the payments are happening at the beginning of the period, no pun intended. So if it were to occur at the beginning of the period, you would go right here within our timeline. And as you can see, right above the little box here, you notice that our payments, they start at T0 because they're starting at the beginning of the period. They're starting today, okay? And that's really the nuance of what this is all about. And we're going to talk and address the nuance between this concept a little bit later once we get to the formulas, but still very important to understand. Now, if we're dealing with something, as you can see it on the flowchart. If we're dealing with a payment that's for a defined period of time, right? It starts at one date, it finishes at another, and it's occurring at the beginning of every single year, period, or whatever, we're dealing with an annuity due, okay? And with an annuity due, you have 2 formulas, PV and the FV. Use these formulas, they're in front of you. Super simple. Now, on the other hand, if we were to deal with payments that are occurring at the end of the period, we would go up here within our flow charts, right? You would be on your exam, you would read the paper, and you'd be like, okay, they told us this is happening at the end of the period. So you know exactly where to go onto the flow chart. you need to go right here, okay? And notice how at T0, we have nothing. The first payment is actually happening at T1, okay? Very important to know where to put your payments across your timeline, all right? So far, so good. The next step, if we were to see that payments are happening at for a defined amount of time, and that we know they're happening at the end of the period, the last sense check that we need is to figure out whether these payments are going to be defined, so they're going to be the same one every single year, or if they're going to be growing every single year thanks to a growth rate. In the question, they'll tell you, hey, this payment is going to increase. Notice here that we see 30, 45, 60, 75. These payments are growing by $15 every single year. So these are growing payments. And if they are growing payments, you need to deal with the growing normal annuity formula. Notice that with the growing normal annuity formula, you only have one formula to use, which is the present value formula, okay? Very important to understand that. On an exam question, if you're dealing with such a scenario, well, you only know that you can only use one formula, so use that one. On the other hand, if these payments are defined, they're going to be the same ones every single year. You're dealing with a normal annuity, and that is a present value or a future value formula, okay? One last thing that I'd like to note before we move on to the undefined set, so the perpetuities, I would just like to tell you something super quickly. Notice how the formula for your normal annuity, let's take the present value formula. Notice how it's equal to PP0 is equal to payment over K. Oh, okay, well, the difference between a growing normal annuity and a normal annuity is quite literally the fact that the payments are growing every single year or period. So in this case, notice how it's 30 bucks, 45 bucks, 60 bucks, 75 bucks. This is 30 bucks, 30 bucks, 30 bucks, 30 bucks. So this goes beyond the idea of compounding interest. This is still within the same realm, but the notion of having growing payments simply means that you're going to receive some payments that you're going to invest every single year, okay? But those payments that you're receiving, all right, are going to be growing by a growth rate on a year-to-year basis or on a period-to-period basis. So you want to address that. This is no longer a simple annuity where those are normal payments. So let's say $1,000. Actually, I'll give you a better example. I'll give you a really good example, and then William, I'll address what you just put into the chat. All of us are, in our degree, right? We're hoping to graduate to get a really good job. But once we get our job, obviously we're going to be super smart, people. We're going to get some money. We're going to pay, for our apartment, pay for the stuff that we want. But we're also going to save money, right? We're going to save money and invest. However, that money that you're going to invest will be literally a function of your salary. Hopefully, your salary increases every single year or like every single 2 years, 4 years, or whatever. Now, as your salary increases, right, the more you will invest by the same amount to a certain extent, by that same ratio. So that's what we call a growing set of payments. You're going to make a growing set of payments to your investments, right, to the stock market or whatever you decide to invest in. Because from your salary, you invest money. But if your salary increases by, let's say, 5% every single year, well, then your investments would also increase by 5% every single year, assuming all is constant. So that's a growing payment. That's a growing normal annuity, right? That's why we need to address this idea of that growth rate. Because when you're going to look at your future and the future value of your investment, you need to address, you need to consider, you need to compensate for the fact that those payments are going to grow every single year. Now, on the other hand, a really good example is perhaps our parents, right? Our parents are probably at the age point or at the point of their career where their salary may not increase, let's say, that they get a fixed amount and that's what they're dealing with, for the rest of their career. But they still decide to invest or to allocate funds somehow. Well, the funds that they may allocate, call it a function of their salary, will be essentially, call it 10% of their salary. But because their salary does not increase up or downwards, it does not grow or decrease every single year, their investment will be the same every single year, right? So we're dealing with a defined set of payments. We're dealing with a normal annuity. We don't need to assess any growth rates. That's the difference between growing payments and defined payments. That's the notion of the growth rate, where you're trying to address, well, obviously, if your salary, if the money that you're going to place into your investments is increasing, well, we need to account for that through our formula and through our calculator, through the growth rate. Okay, that's the idea. Hopefully, will lead that gave you a sort of understanding of why it's not really compounding the growth rate. The growth rate is just a function that's going to increase, the money that you're investing that will then be compounded on a year-to-year basis. So yeah, William, great question. In a normal annuity, the payments, so if we were to maybe go back into our flow chart, our payments right here, okay? Our payments, well, they're gonna be the same, right? Because they're defined. So call it 30 bucks every single year for 10 years, okay? Those are defined payments, the same payments for those 10 years. They're not growing, they're not decreasing, they're not changing. That's when you're dealing with a defined payment. It's like defined, like it's definite. It's not changing anytime soon, and it will stay like that. Okay. So last thing I'd like to address, last thing I'd like to address with the idea of the normal annuity is that if we look at the formula, payment over K times 1 minus 1 over 1 plus K to the power of N. Okay, that's the formula that we have right here. So far, so good. Notice though, that when we go back to our annuity due, we also have a very similar formula. Payment over K times 1 minus 1 over 1 plus K to the power of N. But the only difference, could somebody tell me what is the only difference between these two formulas? Could somebody tell me? You should see it. It's very visual. It's like in front of you. What is the difference between the normal annuities present value and the annuity dues present value? Could you tell me? What is the difference between the two? It's in front of you. I need a lot of people to write it in the chat. Bianca could be right. I don't know. Who knows? I need a lot of people to write it in the chat. Tell me, what is the difference between the normal annuity present value formula and the annuity due present value formula? Bianca says it's 1 plus K. More people, can you tell me what the difference is? William says yes. One more person. I guess I'll ask Waleed. Waleed, is this, what's the difference? Yeah, solid. That's the only difference between the two formulas. Notice how it's also applied to the future value formula for both scenarios. The difference is only 1 plus K. Now, I think we could all agree to this point that 1 plus K is essentially an additional compounding period, right? Remember our formula? Call it X times 1 plus K to the power of N. 1 plus K represents a compounding period. So in this case, we're telling you, hey, with your annuity due formula, okay, this could be an exam question, and it's important to understand. With an annuity due formula, you're simply compounding for one additional period, okay? You're simply accounting for one additional period of compounding interest, which is why if we go back to our timelines, notice how right here, the payment begins at t equals 0, okay? And here the payments begins at t equals 1, all right? That's essentially what this is telling us. I got you. So Marianne, I'm going to ask you a question quick. In the group chat, if you go into files, which I'll add you in, you'll see the Comp38 MT1 course pack. Within that, you have the formula sheet, literally all high definition and provided to you. Like it's very big, you'll love it. And yes, I'll add you to the group chat and the recording will be posted for everybody afterwards. But yeah, so that's the difference between, the annuity due and normal annuity. Now, if we go back to our formula sheet, okay? I mean, to our flow chart, notice how we talked about all the different types of annuities. Now we need to go back to our perpetuities. Once again, the sense checks that we apply to our perpetuities is, okay, are our payments happening for a defined or infinite amount of time? If it's happening for an infinite amount of time, in other words, there's no clear endpoint stated in your question, you are dealing with a perpetuity. Now, the second sense check that we usually do, which is, well, is this happening at the beginning or at the end of the period, we don't need to do for a perpetuity. Don't ask me why, we just don't do it. All right. So we get to move on to the third sense check, which is finding whether these payments are going to grow in perpetuity or are these payments going to stay the same in perpetuity. All right. So this is going to be like stated in your question. This is going to be kind of just stated in the question. Don't even worry about it. That's how it goes. All right. So with that, you have two types of, places to go within the flowchart. And within those places to go within your flowchart, you're going to have two formulas, the growing perpetuity formula and the perpetuity formula. All right. Now, realistically, the perpetuity formula is super important to understand. It's PV is equal to payment over K. It's as simple as that. You're just taking the payment that you're going to receive, call it 30 bucks, and you're dividing it by the interest rate that's provided or your opportunity cost. Okay. Just remember that you're dividing it by simply the percentage. So if it's $30, you're going to divide it by 5%. Okay. So just remember that it's not 1 plus K, it's just K. Now, an additional note to have is that your formula for a perpetuity is going to tell you that PV0, okay, is equal to payment 1 over K. Okay. In other words, you could also say that your formula is telling you that payment N is equal to, PVN, so sorry, PVN is equal to payment N plus 1. All right. That's super important to understand. And I'm going to trick you guys and I'm going to ask y'all to give me some answers. Okay. So if we know that payment is at period 3, what will be the value that we're going to put right here? What would this be if payment's happening at period 3? William says 2. I need at least 5 people to give me the answer. This should be super quick and easy. If payment is at period 3, when is our present value? All right. When is our present value? Walid says 2. Yanka, Brandon, Marianne, Vanessa, Yusra, Vince. What do we got? What do we put in here? Marianne says 2. One more person for fun. Exactly. That's amazing. Okay. So then I'm going to throw at you one last little joke. So if this is 8, okay, what is this? Somebody tell me. If this is 8, what is this? Last question. Okay, 9. Amazing. All right. Super good. You guys are like almost pros. That's so cool. Now the last part is going to take maybe 1 minute to cover. It's simply the idea of, okay, sure, on an exam, now I know what to look for. I know that I need to look for whether the payments are going to happen forever or are they going to happen for a specific amount of time. And once I do that, if they're happening for a specific amount of time, I'm going to ask myself whether these payments are happening at the beginning of each period or at the end of each period. Then, regardless of what scenario I'm dealing with, I need to figure out whether these payments are growing or whether these payments are going to stay the same. Once you know that, okay, you know what formula to use, but what are the inputs that we need? So let's take a quick deep dive into the inputs that we need in such a time value of money question. So if you were keen enough to look at every single formula, this one, this one, this one, this one, this one, this one, and this one, you would notice that at the very end, there's only quite literally, I guess, maybe 4 things that you need to look for in a question. And we're going to define those. Those 4 things that you need to look at, these are the only things that you need to find or derive for in a time value of money question is payment. Okay. Notice how that's gone. K, that's gone. G, that's gone. N, and that's it. You only need to look for 4 things on an exam question: payment, K, N, and G. And G might not even be there. Sometimes you don't even have a question that deals with G. So now you're empowered to literally know exactly what to look for on an exam. You don't need to look for the size of the earth. You don't need to look for anything else. G is the growth rate, right? N for number of years, K for the interest rate, G for the growth rate, and then payment, PMT for payment. These are the only four things that you need to look for. Nothing else. There's like nothing else I need to look for, okay? Sometimes questions will give you only, for example, three of these, okay? And they're gonna ask you to solve for the other one. That could happen, but you now know that you only need to look for four things. Once again, no pun intended. That's super, super duper important. All right, so when you see and when you prepare for questions like these on an exam, you should not be lost, right? At the end of the day, the first thing that you want to do is highlight important pieces of the question. Then figure out what formula you need to use in this question. Then three, literally, I do this to this day. Write down payment on your paper, K on your paper, G on your paper, and N on your paper. Write them down and then look for them in your question. Once you've written all of them down, all you got to do now is plug them in within your formula. At the very least, that's the minimum that you should be doing for every single question. After that, if it didn't give you the correct answer, then you get to kind of finagle it a little bit, play with it. But it's very rare that you get to that point. Okay? Also,